tonight we have Kathy Sierra here, who's going to talk from her perspective as a senior Brookings Fellow and on global climate change and development, and both issues of interest to us here in Nevada. And Kathy is also a senior fellow at Brookings and also has a former executive at the World Bank, so she has a unique perspective on this topic, and I know you'll have some interesting questions for her after you hear her talk. Kathy?
Great. Okay, thank you. Thank you, Bill, for the introduction, and welcome everybody. It's really a pleasure for me to be here in Las Vegas, the University of Nevada at Las Vegas, not just because I'm originally from the West, I come from California, but because many of the issues that we're going to talk about today, which really I'm going to be focusing on the developing world, have resonance, I think, with some of the issues that I've heard from colleagues here in Nevada and Las Vegas, in particular about the impacts of climate change in the future, and especially the opportunities from clean energy, which I'm not going to go into in detail today, but also the specter of exchanging climate on water resource management, agriculture, water issues in the region. So as you're listening and thinking about the impacts of climate change on the developing world, maybe we can map back into a little bit of what we see happening in this region itself. So we're going to be talking about climate change and development, thinking about the poorest communities of the world as well as those in middle-income countries, and focusing mainly on the adaptation challenge. Why am I interested in this? Is because we know that the climate is changing. We'll talk a little bit about the science. We know that mitigation is critical, and we'll talk just a bit about why mitigation has to happen and what the trajectories look like. But even with mitigation, with a fairly aggressive mitigation and reductions in greenhouse gases, adaptation is going to be needed. And indeed, what we'll see from the evidence is that in the poorest countries, they're maladapted to today's climate, much less the climate of the future. I'm going to talk a little bit about the links with economic growth and development, because economic growth and development is one of the best adaptation solutions going forward. But that adaptation and growth and development has to be different. It's about building resilience into economies, into peoples, into societies. And so what I'll take you through are 3 case studies, one on sustainable agriculture, the second one on water resource management, and finally looking at disaster risk reduction and some of the strategies that we're seeing in the developing world in those 3 areas. So the international panel, intergovernmental panel on climate change came out in 2007 with its conclusion that the climate is changing, this is unequivocal, and that it is highly likely, and this is in science speak, in fact, most of us take this highly likely as it is known, that this is because of man-made forces. So this slide shows you not the big hockey stick, which you may often see when you see a climate change presentation, which shows that for millennium, the climate was fairly stable at about 0.7 degrees Celsius up and down, changing dramatically after the industrial revolutions after 1750, with temperatures on a relentless creep up. Many people ask, but how do we know this is man-made and not just through natural forces, through solar activity, volcanic activity, and the like? And here are some models that were created by the IPCC, with the black line showing over the last 100 years what the changes in the temperature actually are. The blue bar, the models that show what would have happened if you only had natural occurrences happening during that period. And the pink was the models, about 30 models in this consensus, showing what happens when we add in those hypotheses of what was going on with human activity, and specifically human activity, the burning of fossil fuels and other chemicals that are adding to greenhouse gases in the atmosphere. So this is telling us that there is a change, and that change has to be reckoned with, and that change is also in large part responsible because of human activity. So we have a responsibility on both the mitigation side to reduce the rate of that change, as well as recognizing that there are changes going on in the climate system that are going to call for adaptation today. This slide, again familiar for those that follow the climate change discussion, shows what the impacts of temperature at various different future scenarios of degrees Celsius over pre-industrial levels. We're on our way to a 2-degree world increase over pre-industrial levels. If we could actually stop the climb beyond that, we would be very lucky. There's only a 50% chance that we will be able to halt climate change to 2 degrees. On the this side, left-hand side, was what the climate scientists thought was going to be happening based on data in 2001. The red embers, as it's called, the burning embers slide, shows of what the kinds of risks that would be out there. Risks to many, large increases in negative weather events. What's the distribution of impacts? Is it going to affect a lot of communities, a lot of regions of the world, or a few? What are the various metrics and the like? And what I want you to take away from this slide is the difference between the two. Because while clearly the scientists were worried in 2001, you notice that it's getting redder as we get closer to the 2 degree Celsius line, and in all of the hazards that they were talking about. And that's because the science is really starting to show that the impacts of these changes are starting to have more disruption than people thought in the systems, the natural systems of the world. So one of the things that has been agreed as part of the international climate negotiations is that given the probabilities, and knowing that there are a lot of spread in those probabilities, but given the riskiness, that the international community has said we're going to try to keep our temperature climb at 2 degrees Celsius. So what does that mean? In the green bars would be, well, actually the orange is where we are going today without any changes. And so this is business as usual. These are based on various models that say if we don't do anything in terms of changing our fossil fuel systems, changing our energy systems, our patterns of agriculture, our patterns of forestry, degradation, we are on the trajectory to the kinds of global emissions that are going to take us to a 5 degree world, which would actually be quite catastrophic. If we want to get to a 2 degree world, we're going to have major reductions in greenhouse gases and global emissions over the next 50 to 100 years, which is not going to be easy. It's really talking about major transformations in our energy systems, our transport systems, how we form our cities and the like. And so that's going to take international cooperation, because the earlier emissions are really the responsibility of the United States, the OECD countries, Japan. But future emissions, growth of emissions, is going to be coming from the industrializing world, from Mexico, from China, from India, South Africa, and the like. And they have a very low energy intensity, but very large populations, and those populations would like to be able to develop as well, which means that they're going to be using more energy and more resources. So how do you help them move towards the trajectory we all need to get to 2 degrees? It's going to take finance, it's going to take technology, it's going to be taking really reimagining what a system that allows for both growth and development for their people, but also a new way of doing business. Now, why should developing world care? And many people in the developing world that I dealt with when I was at the World Bank and talked to now 5 years ago would tell us, this is really the problem of the West. It was created by the West, they're worried about it, we have to grow. And our job is to grow, and we want to use cheap energy and the same kind of aspirations for vehicle use that you see in the West. But the evidence has started to become very clear that while the emissions were put into the atmosphere by the industrialized world, who took advantage of the energy sources to be able to grow, the impacts of global warming and climate change are going to be felt in particular on the poorest countries. So this chart talks about the biggest hazards out there: drought, floods, storms, and the like. And what you notice in yellow are the wide swath of yellow. These are the poorest countries of the world who are the most vulnerable to these kinds of risks. The blue are the rapid industrializing countries. And you'll notice in the green, there's only 3 OECD countries: Netherlands, Japan, and Denmark. So while we're concerned in the United States and in Europe about the impact of climate change, it doesn't even rise to being on the top list in terms of hazards that are out there. So the countries in the developing world are worried, and they're getting more worried as we're starting to see catastrophic changes in the climate. So let's go back to what's in the developing world and what do they want? Well, they want growth, they want prosperity, they want people to be able to be moving out of poverty, and they see that they have many people they have to contend with. A quarter of the population in the developed world live on less than $1.25 a day, which is the kind of number that we track in the development world of the lowest poverty index, lack of clean water, lack of electricity, sanitation, malnourishment. So we have to help countries find strategies that are going to solve that problem, but also move into new ways of doing business, both in terms of emissions and in terms of the systems that will help growth. Agriculture, for one, for example. It's going to make development even harder because the costs are going to go up and the kinds of risk profiles that countries are going to see will be more difficult. We also know that part of the problem will be solved if countries get richer. As countries get richer and people get richer, economies tend to be less reliant on climate-sensitive sectors, agriculture in particular. The private sector tends to function better, and much adaptation is going to actually have to go through the private sector. They own the real estate business. They're part of this in big way. Stronger governments tend to be also correlated with countries that are more highly developed, and those countries will have better institutions, better early warning systems, better capabilities to be able to meet a riskier future. And with a reduction in poverty, communities are stronger. They have a better ability to adapt, both at the family level, but also the community level. And the community capacity to cope will be a very important part of the overall equation. But again, as I said earlier, it's going to demand a new way of doing business, and we're really just imagining what that new way of doing business is. Really, there's no blueprint for this. So let me take you through three examples on agriculture, water resource management, and climate disaster risk reduction. So why do we worry about agriculture? I think it's probably not something that's a big surprise for us in this region, but we're going to be seeing depressions of agricultural yields in most countries by 2050. The red is bad. You don't want to be in the red zone. Green, maybe you're going to be seeing some improvements in agriculture productivity, but even there, not so clear. Why is this? You're going to have more heat stress, more pests, less water, going forward. And so it's going to take some very new adaptive technologies and practices to be able to meet the needs. But at the same time, we also know that agriculture can be part of the solution to a changing climate. Greenhouse gas emissions don't just come from energy use and transportation use. They also come from changing land use, moving forestry into agriculture or low-grade agricultural productivity. They come from bad agricultural practices. So almost 30% of greenhouse gases could come or do come from agriculture or worsening land use patterns. If you find a way to reverse that and actually do that in a way to increase agricultural productivity, it's one of the classic win-wins in this game. So what are the strategies? As we think about strategies, we also have to remember that by the end of the century, you're going to have 3 billion more people on this planet. And those people need to be fed, and those people are going to have diets that are changing. And those diets that are changing tend to be more energy intensive, more meat use, milk, and the like. So a lot of strategies that we actually know about will have to be put into place, but with much more vigor. Things like zero tillage, instead of having the fields tilled, using precision techniques to water, to fertilize, to plant the seeds. This saves resources, fertilizer and water. It actually is more labor intensive, so it's good for the developing world, and it can boost productivity. There's a lot of investment going on in R&D for drought and flood resistant crop varieties. An example is in East Asia, they have now new rice varieties that can resist floods for over a month. In Africa, there's work on new crops that can withstand drought. Revamping of agricultural subsidies, which actually today push you towards fertilizer, push you towards intensive use of water and a lot of water wastage. If you move those subsidies, if you need them, but let's say politically you want to have a subsidy system, then use that to be able to push people towards using some of these new and improved agricultural techniques and the like. Better irrigation, better monitoring and remote sensing, a lot of opportunities coming from new technologies. And then finally, incentives for sequestration of carbon. and a lot of discussion going on in the international community about finding ways to credit, especially poor farmers, for conserving carbon through good agricultural techniques, and thinking whether or not the carbon markets could be able to give credit for that. So it's going to take a lot of basic science research, it's going to take a lot of policy changes, and using indigenous knowledge as well. And so here, one of the points is that to listen to the communities, because often they know what are the strategies that may be needed as we go forward. Water resources management. Now, we also know that water availability is going to change dramatically by the middle of the century. Again, here, you don't want to be orange, and the white doesn't mean that they're in good shape. It means that the models don't agree with each other. Let me just make that caveat. I think that you all are here in kind of orangey, which is not so good, which says that you're going to have a dramatic decrease in water availability, either through runoff or through the weather patterns. You're also going to be seeing more intense rain in many other regions of the world. And intense rain can be as damaging as too little rain. And so you have some areas that are going to have too much water and others that won't have enough water. And so ways of being able to store water, to be able to transfer water, to be able to conserve water are going to be very important in this new experience, this new way of thinking about development. So it's going to be more challenging. And here I'm not going to go through all these, but these are some of the things that are going to be happening. We're seeing loss of snow cover and glacier melt. That's going to be impacting, an example I'll give later, what's going on in the Andes. Flooding that's coming from deforestation, getting more acute, more intense rains, more tidal surges in the coastal areas, more difficult groundwater management, and greater uncertainty. And so I think that is one of the takeaways for you all, is that the people that worried about water resource management, it was difficult and institutionally very difficult. Water right management's very difficult. Conflict over water, very difficult. But at least the engineers thought they knew what a 100-year flood looked like, and how to at least engineer the kinds of solutions that might be useful. We don't know any longer in many places what that flood pattern is going to look like. And so the kinds of engineering solutions, the kinds of certainty that planners had is no longer there. And so we'll have to think about having a range of options, having more resilience to a wide range of options, and not necessarily engineering to a unique solution set, but engineering and planning for much uncertainty. There's going to be a need for a lot more water storage, flood protection going forward, but take advantage of that also to improve irrigation systems and to produce energy. Ecosystem approaches, I think, will become much more important. Again, often in the climate world, in the developing countries, people think first of the built environment, of flood protection, and they think of resilient infrastructure, and that's going to be needed. But we also need to think about the softer side. We need to thinking about using natural environment to be able to use as a buffer against a changing climate, especially in the coastal regions. And information, investing in information, early warning systems at the community level, as well as those that will help decision makers at the regional, national, and global level make decisions in the face of water uncertainty is going to be critical. So just some examples. People are very worried about mountain states, and in particular in this hemisphere, quite worried about what's going on in Peru, in Ecuador, and in Bolivia, where there is very striking evidence of reduction in the glacial cover. And communities basically have for millennium relied on those glaciers for water, for the poor that live in those mountain regions, but also for the runoff to be able to provide water supply to the cities, which are often in the coastal regions. We're seeing crises happening in Peru and other places where we're projecting, or scientists there are projecting, that we may be losing those glaciers in a period of less than 40 years. Communities are having to adapt very quickly. Some are having existential discussions about whether we can actually live in the mountains any longer. New water supply systems will have to be built, new storage systems will have to be built, and new farming practices will have to be introduced in places where these have been unknown. So you'll probably be reading quite a bit about this as well in the Himalayas and the like, as well as some of the glaciers in Europe, but I thought I would bring you first to your own hemisphere. Africa. Africa will be and is already experiencing drought and flooding simultaneously. But they also have an advantage and they have an opportunity. The advantage is they have a lot of water resources that are untapped. And if we think about the water resources that have been exploited for hydro, either for storage or for energy, in sub-Saharan Africa, it's about 7 to 8% of the available water resources that could be exploited for energy have been used. So it's very small. In the United States, as a contrast, it's about 55%, something of the sort. And so you've got an energy problem in Africa, you've got a water problem, and so many are looking towards one of the solutions, not the only solution, being exploitation of water resources. And if we do that, perhaps part of the energy access issue in Africa can also be solved. This is a map of the world at night, and you'll notice how dark it is in Africa. That's because almost 600 million people in the continent do not have access to modern forms of electricity, which has health impacts, it has growth and development impacts. And so if you can harness the water as well as other sources of renewable energy, like geothermal, like wind, like sun, you may be solar, you may be able to both help Africa develop as well as bring real poverty alleviation benefits to the poor in that continent. Finally, climate disaster risk reduction. I didn't want to start here because many people think that in climate we just have to make sure that we are planning well for the inevitable disasters. Now we do have to plan well, but there are strategies of prevention that are now being considered, being put into place by many communities and countries in the developing world. So let's remind us a few facts. One is climate-related disasters are increasing. Now the number of people dying from those disasters has gone down, okay? But the number of as a percent, but the number of people affected by climate disasters is going up, as well as the percentage of the population. And this has a lot to do not just with the climate, but it has to do with urbanization. There's more people living in tighter communities. Many of those communities are in the coastal areas, which are more vulnerable than other places. And so you've got an impact that's moving through. Happily, not as many people are dying from this, but the impact is just as acute to those families that may be losing their housing, their livelihoods, and the like. So what are the strategies on climate risk reduction that we're seeing being put into place in the developing world? And here we usually talk about hard measures and soft measures. The hard measures are the infrastructure pieces, the barriers against tidal surges, against flooding, and the like. Those are going to be important. They're not going to be enough, but they will be important. So smarter infrastructure, roads that have the kind of drainage that may be required, water systems that will be more resilient to flooding, city formation, and the infrastructure that has a better, frankly, and more expensive infrastructure that can withstand shock going forward. Ecosystems management, again, a lot of discussion and planning is around the trade-off between where you site your cities, where you have people living, versus using the natural systems to be able to help provide a buffer from a changing climate, as well as by reforestation and the like, providing more resilience to the overall ecosystem in the region. So much of the planning will be not just for building better infrastructure, but for using the natural ecosystems in a more resilient way. And coastal planning and zoning will be very important, very hard. And I'm sure from your own experiences, everybody wants to have that house at the beach. It's going to have to require really more strict land use planning to both make sure that we're not building in sensitive zones, but also that the poorest are not forced to live in those sensitive zones. In the developing world, the poorest tend to live in the really bad land. They tend to live in floodplains. They tend to live in the sides of hills, in cities that are more prone to mudslides, and so they're impacted first. And so finding solutions for that will also be part of all this. Soft measures will be as important, and frankly, a lot of the investment going on right now is in this area. So early warning systems being put into place to be able to have a warning of what's happening in the climate. It's also being done for other forms like tsunamis protection as well, taking the information not just coming in from the national level, but getting to that last village and the last villager through community systems, through new uses of cell phones, ICT, radio systems, and the like, so that people can prepare themselves and can move in the face of disaster to get to shelter. Safety nets. Bangladesh is a good example of this, where they have a system that has safety nets that can expand if there's a disaster. So they have food for work programs that provide support for the poorest families in Bangladesh. They have other feeding programs that provide support for the poorest families. They've been developed and the institutional infrastructure is in place. So if there's a disaster in one region of that country, they can quickly expand those types of feeding programs, food for work programs, so that you get immediate relief to families that might have been impacted. Community-driven solutions, really wonderful stories coming out about schools that are training the children in the schools to basically be the early warning systems for their families. They may be the only literate individuals in their families. They may be part of that chain of early warning systems. And they may also be able to help foster the kind of dialogue that has to go in communities about how do we prevent. So in Mozambique, which is prone to flooding, they brought together the community of farmers to say, well, what are we going to do? And they brought solutions about new types of barns for the cattle, where they should be siting homes and farms because of known weathering patterns and the like. So don't forget, it can't all just be top-down. A lot of bottom-up solutions could be useful. And then the insurance markets. Building in as much resilience and prevention as you can into individual, private sector, government decisions, but also providing some insurance to be able to spread and offload the risk. So a few examples: coastal resilience in Bangladesh, Calcutta, one of the most disaster-prone countries, cities in the world, with a country that already faces huge flood risks and every year has to cope with this, has basically the full menu that I outlined in place. And they're really on the very forefront of thinking about how to build a society and an economy in a very risky situation. And so a lot of the innovations that other countries are looking to are coming from Bangladesh, which is part of a region, the South Asia region, which is particularly vulnerable. East Asia. Most, and we'll get to the cost in a minute, the price tag of all this has the highest costs that are being forecast with respect to the cost of adapting to a changing climate, and that's because they have many megacities that are sitting in very vulnerable parts of the coastline. This slide is a slide that overlays vulnerability in red with big-time real estate development that's going on in these regions. And so that's just to tell us that while we know where the vulnerabilities are, real estate projects are being approved as we speak. And those real estate projects probably are not yet being built and being approved with the kinds of zoning and the kinds of expectations that are going to be needed for a changing climate, which is a pity because we know that infrastructure is being laid down for 50, 100, 200 years. So now is the time to make the changes. So countries are starting to think about their land use planning. They're using international resources. Again, when I was at the World Bank, helping Metro Manila think through what should their land use plan be. How should they bring the private sector in to help think about this? How do you protect the poorest and how not to make mistakes of laying down infrastructure that's inappropriate, knowing that you're in a risky area. And then finally, catastrophic insurance. We all know that the Caribbean is often subject to hurricanes. And the cost of those hurricane destruction is going up. We know that the number or the magnitude of the kinds of hurricanes are increasing. This shows projections of the percent damage to GDP that we might be able to expect by 2030, and the message there is things are getting worse. So that means that those countries have to take pretty aggressive action now to build better, to take preventive measures, both in terms of where infrastructure is put in place, the sighting of people, early warning systems. But only so much of that risk can be offloaded and can be prevented and reduced. There will be some residual risk that's there just because of the vagaries of the climate and the weather systems and patterns that are coming. So there's been an experiment going on for the first regional infrastructure pool that's in the Caribbean, where the Caribbean countries have banded together with support from a number of major countries that are providing the financial backing for this to go into an insurance pool that, one, helps them think through the prevention piece so that we don't have a sort of a negative incentive there to get paid if there's a disaster, expectation that there's prevention being moved in, but then knowing that when you have a disaster, one of the biggest problems the country have is liquidity, because they have to make payments right away to be able to provide support to those that are most needy. So this insurance basically is triggered by the size of either the earthquake, it covers earthquakes as well, or the storm. When it hits a certain level, a payment is made. And recently, I think it was in Cyclone Thomas, I believe, there was about a $12 million payment made within a day of the cyclone hitting for 3 states to provide immediate liquidity and to help them manage through the crisis immediately. I think you're seeing a lot of countries that are quite interested in pooling their risk, be able to spread the risk, and providing insurance cover for them as they go forward. So this is really expensive stuff, so this is not inexpensive. So there's been a lot of work going on saying, well, what really is the cost of adaptation? What's the bill? And many different studies, but they're all coming around the same number. This is a quote of this $75 to $100 billion per year that comes from a recent study by the World Bank called The Economics of Adaptation. And the reason for the range is they use different climate scenarios, a dry scenario and a wet scenario, and you get different numbers depending, but it's a fairly large number. To put it into context, that number, about 100 billion, the top end, is equal to all of the overseas development assistance that the poor countries get from the rich world. So about $100 billion per year comes from the United States, from Europe, from Japan, and the like, to support basic development. So the 75 to 100 basically doubles the cost. Where are those costs? The biggest cost is going to be in East Asia, and not necessarily in the poorest countries there, but in East Asia, because of the cost of that urban infrastructure that I talked about. Latin America is the next cost center. But what's interesting is if you look at this as a percentage of GDP, and this is why we're all so worried, Africa is the hardest hit. So the costs are a little bit lower because there isn't as much urban infrastructure, people are living in rural areas, they're hit in different ways, their assets are not as big, so the losses aren't as big, but the human cost can be devastating, and the economic cost to those economies that are struggling to grow is going to be relatively large. And so that's why in the climate world, many people say that the kinds of financial assistance that may be forthcoming should be focusing on the least developed countries, Africa, sub-Saharan Africa in particular, but also small island states that may really be threatened in particular from sea rise. So least developing countries are really looking for financial support. They say, we didn't cause this problem. We were minding our own business. For the last couple of centuries, the industrialized world grew. They admitted, they changed the climate. We're basically paying the price for this. So they are looking for financial support, and the international community has agreed that that is something that should happen. So where are we now in climate negotiations? Just came out of a meeting in Cancun. Every year, the climate negotiators get together, and they try to move towards a global pact, a global agreement on what to do about the changing climate, both in terms of how to mitigate greenhouse gases, but also what to do about the inevitable adaptation that is going to have to happen. So way forward on mitigation was achieved first at the tail end of a very bad meeting in Copenhagen a year and a bit ago, but solidified in Cancun, where countries have put out their mitigation plans, both in terms of the United States, Europe, Japan, and the like, but also China, India, Brazil, Mexico, South Africa, Colombia. There's no goal except for that 2 degree as the headlight. It's a start, but when you add up all these agreements, it's really not enough to get us on a trajectory to 2 degrees. But it's better than where we had been a couple of years ago. So I think while many people that follow this issue are disappointed that the cuts that have been pledged are not deeper, we're going to take what we can get. And frankly, the leadership of the United States is lacking in this, and that is part of the reason why other countries have not been willing to pledge in a stronger way. But it's a start. Principles for adaptation responses were agreed. Now that's, you say, why is that controversial? A lot of concern had been if we start talking about adaptation, it's going to take the pressure away from countries to actually reduce their greenhouse gases. And so there was some concern that too much attention on the adaptation challenge may take us away from the other. But I think now people are more comfortable that we're going to have to do both, and starting to be comfortable on some of the concepts and the pieces of the puzzle that have to be put together, knowing that it's going to need a lot of knowledge going forward. And then finally, financing, which is important both for getting to an agreement, because frankly it's an international negotiation, and the developing countries say, we need to see some finance to be put out there. What was agreed was in Copenhagen, then reaffirmed in Cancun, was that between 2010 and 2012, the developed worlds will provide $30 billion over that 3-year period in what they call fast start funding. And that is for both mitigation support to help countries move towards a clean energy future, as well as support for adaptation activities. Most of the money, unfortunately, is, well, I don't know if it's unfortunately or not fortunately, but it objectively is going to mitigation, not as much as going to adaptation. Going forward, what's also been agreed is that by 2020, the world should be seeing $100 billion in finance for both mitigation, again, and adaptation to be provided to the developing world. And the expectation is that the adaptation money will go to the poorest countries, the sub-Saharan Africas of the world, the vulnerable small island states, and the like, as we go forward. So here we are. We have some positive news in terms of the world is starting to recognize where we're going. We have negative news in terms that I think, don't believe, or I don't believe, and my colleagues don't believe that enough is being done. We have some really good examples that are coming out on the adaptation side of countries and communities that are trying to grapple with this. But we also know that we have huge knowledge gaps. We actually don't know what the most cost-effective movements are going to be. We don't know how to do the right mix of institutional, soft, and hard engineering. We know it's going to cost a lot, but we also know there's great variability in what those costs are. So my message to the university, to you as students, is to invest in research, to invest in knowledge creation, to invest in your own communities to see if we can make this forward, because this is going to be the challenge of your generation, and it's going to be the challenge of your children's generation. So a little bit of knowledge coming from the developing world may also help us get out of what I think is going to be a very difficult period going forward. So with that, I thank you, and happy to take questions. And I don't know if you want me to moderate, Bill, or? Okay, so questions. Yes?
You said the government of the United States is lacking. Are you talking about not moving forward with cap and trade, or not moving forward with any legislation at all on climate change?
There was two things. With the developed world, say Europe, for example, Japan and others, as well as the developing world, we're looking for fairly steep cuts coming from the United States, partly because the United States, having not gone into the Kyoto Protocol, was seen as behind, and also because the US is the largest historical emitter, and so people kind of use that as a benchmark to say where they should be. Now, two things happened. One, I think the administration, and here as opposed to the country, I think understood what the limits of or the policy conversation was in the United States. And so they were very forthright from the very outset that a 17% reduction in greenhouse gases over a 2005 baseline was probably as good as it was going to get, at least in the first period, with an expectation that you would have deeper cuts with technological transfers going forward. That was predicated on having a cap and trade system. It could have been a tax, but something that would provide a price on carbon. And that's what they went to with Copenhagen and then again to Cancun. It was seen as not enough, but also the real politics set in and said, well, that's what it is. And I think the negotiators, they played the card that they had in terms of what was actually feasible in today's environment, and they were very honest and upfront about it. So people were looking for more, but I think accepted that that was where it was going to be. Now, those numbers were created when there was an expectation there would be a cap and trade system put into place. That's no longer the working assumption. So
The
17%, no, the cap and trade. So there's been some modeling that's been done to see can you still get the 17% reduction. And the World Resources Institute has done that modeling, and it's available on the web. They basically say if you take all the state efforts plus all the EPA authority and some other tricks and trades, maybe we can get 15% reduction. Okay, so, and that is going to be with every trick and with no problems in terms of passing things at the state level and no barriers to the EPA being able to use the authority that they believe that they have. So we're in a tricky place. Most observers of U.S. policy say the action is going to be at the state level, and so the next couple of years, I don't think you'll see too much action going on at the federal level. It's going to be looking to California, looking to states like Nevada that may be wanting to invest in new technologies and the like, looking to the Northeast for innovation. Any questions? Yes, and I do tricks as well. Yeah.
I was wondering if you might say something about the amount of resources going into propaganda on one side of this issue and into informing people on the other side of the side.
Yeah, it's quite interesting because for those that spend their time working on this, the science is very clear and compelling, and the choices are hard. So I think that there's no illusions that the choices, especially in the short run, as you move to a new energy system, are going to be tough, and you'll have winners and losers. You often have that in policy discussions when we had free trade treaties, for example, winners and losers, and the question is how do you actually provide a transition for that? What's been disappointing is that somehow there was the kind of advocacy, the scientific evidence, basically I think was overshadowed by what we heard from the fossil fuel industry, and particularly the coal industry, going forward. And so that has really, I think, brought down the level of discourse on the issue. There's been a lot of movement to try to discredit the science and scientists themselves. I'm not a scientist, but I do interact with many of them, and they are having their own internal debates. Did we do a bad job of explaining the science? Should we become more advocates, or are we going to actually lose our independence if we advocate and the like? My own sense is for the next couple of years, there's just going to be a lot of ferment around this, and if we can actually show some good opportunities on the clean energy front, as well as opportunities in terms of trade and the like, we may be able to have a more balanced discourse going forward. I know, and I've talked to a number of companies in the clean energy piece who are also having their, wondering why it was that they weren't able to get out the other side of the equation so that a more balanced discussion could be had in Washington, as well as in many states in the country as well. Yes?
Piggybacking on that question, I'm wondering, we have our debate here in the United States. Are other countries having the same debate? Have they moved past that? Have they not gotten to the debate yet? Or is there a spectrum?
Yeah. I mean, it's quite a spectrum. I would say if 5 years ago, and this is when I come from the infrastructure sector, so this was new to me 5-6 years ago, most of countries in the developing world said this is not our problem. Our problem is to reduce poverty, and we're going to do this in the most cost-effective way that we can. And if somebody gives us a boatload of money to be able to move to a clean energy future, we'll happily take that, but it's not our priority. I think you're seeing a shift, and that shift is happening not universally, but it's happening from, in particular, the rapidly industrializing countries. So China, for example, may not be willing to go into a binding treaty on reducing emissions, but they're being very serious about reducing emissions. They're investing heavily in R&D. They're doing that for a few reasons. They need to diversify their energy sources because they're running out of coal, and they see a big vulnerability in terms of coal and use of fossil fuels. So they want to diversify. So they're investing heavily in renewables. They're going to be investing quite a bit in nuclear and the like. Second, they would like to become leaders in the providers of these new energy technologies. And so they are investing quite a bit in R&D and have become the low-cost supplier for many of the new energy technologies going forward. So they're not waiting for other countries to do that. They're moving forward. Other countries are having a bit harder time because there really are trade-offs. It's not all a free lunch. So South Africa, which is I think it's the 11th largest emitter the world sits on huge coal reserves. And they also have, like Nevada, very large solar capabilities. But they have to decide, are we willing to give up some growth because it's going to be more expensive to move to some of these technologies, at least in the first instance, are more expensive, yeah, and have a lower rate of return, to secure a more diversified future that also has health benefits for the local communities as well. So they're grappling with what's that dividing line? Where do we make an investment in our future versus thinking about the energy resources for today? I think if there's not funding and technology that comes with the package, they will decide not to invest in that new energy future because it's just too expensive. But as long as you've got some of it, you're starting to see the developing world, the upper tier in terms of income developing world, move forward. Europe would be ready to move more aggressively, but they've basically said we will reduce by 20% over their baseline. We would have been prepared to go to 30% if others would have gone, and that's code for the United States and China. Okay? That's what that's code for. Japan as well. They would like to have a much more aggressive reduction. Now, whether they actually would do it or not, I don't know, because they know that they're not going to see those kind of reduction commitments coming from the United States. But they certainly have, in their public scenario, said we're not prepared to go any further, but we would be if we saw matching action from the United States and China. So that's a little bit of the linchpin that we're talking about right now. Yes?
Has the recent big push into renewables by China had any effect on the policies in the United States, knowing that we could lose the opportunities?
Well, that's how people are starting to reframe the question. And what you saw first was protectionism. Okay, so we have to stop this. This is terrible. So we're going to go WTO and complain, and we're going to try to stop China from the kind of investments that they're making, that those in the climate world are applauding them for doing. Providing smart subsidies and the like. I think that initial very negative piece has turned, at least in some quarters, to the conversation that you're alluding to, which is we better get moving because because they have more of a command and control structure, they can make the decision, we want to get to this renewable standard, we'll invest in this, and they're doing it. So if the United States doesn't beef up its R&D, doesn't put in the kind of framework, feed-in tariffs and others that will make it more attractive to put in place renewables, smart grids that go with them, we do run the risk of being behind the curve in that. And I think that's beginning. And so in the language, when you're looking at the budget language, for example, or you listen to the State of the Union address, you'll note in the State of the Union address the word climate change was not mentioned, but innovation was mentioned, transformation, clean energy. That was all part and parcel of that piece. Okay. Other questions?
Going twice?
It's all clear. Excellent. Very good. Well, thank you very much. It was a pleasure to be with you.